Now that we know how to actually differentiate, we have to deal with functions that are a little bit more than just 2 bits added together or 3 bits added together. Let's have a look. Look at the examples on this sheet. X squared sine x. We can't find the derivative of that. So all we have to do is we have to use what's called the product rule. And the product rule is this, and you'll need to learn it. You will be given it in the exam, but it is so much better if you learn it. It says the derivative of uv, so if you've got two functions of x, is equal to the derivative of u times v plus u times the derivative of v. What it requires you to do is to set out your questions like this. And if you do this every time, you won't go wrong. So u is equal to x squared. V is equal to sine x. So u dash is 2x and v dash is cos x. Now, using the rule, the derivative of y is going to be u dash v, so it would be 2x sine x plus u v dash x squared cos x. Now, in this particular case, there's very little we could do. We could factorise out an x, but it doesn't matter. You are allowed to use no simplification at all. Let's look at the third one. So this is the third one now. So u is equal to x, and let v equal natural log of x. So u dash equals 1 and v dash equals 1 over x. Now we can just use the rule. So now we've got dy by dx is equal to u dash v, so that's 1 times natural log of x, so that's natural log x, plus u v dash, so that's x times 1 over x. Now you would be expected to do that little bit of simplification, so then you've got that that's equal to natural log of x. There's no difference between this kind of question and the ones that we did in the last topic, except that in order to find the derivative, we have to use the product rule, because this is a product. It's a function times another function. So we need to find the derivative to start with. And the derivative's going to be, righto, let's have u equal 2x squared, and v is equal to e to the negative x. So u dash is equal to 4x, and v dash equals negative e to the negative x. So using the product rule, dy by dx equals 4x times e to the negative x plus 2x squared times negative e to the negative x. It might have been better to put that negative in the middle, but it doesn't matter. Now we just need to substitute in when x equals 1. Do some number crunching. So putting x equals 1 into here is going to give us 0.7353. When you're doing these problems, when you're differentiating, the trick is to decide what kind of thing, what kind of function you've got. Now, if you look in the first one, that's not an example of a function where you've got a product. You've just got 5e to the 3x. So you do not need to use the product rule. That's simply going to be 3 times 5 times e to the 3x. Similarly, the second one is not a product. So we don't need to use the product rule to differentiate the second one, nor the third one. If f of t equals 4 natural log t plus 2, there's no product, there's no multiplication there. The last one, there's no product, there's no two functions multiplied together, so there's no reason to use the product rule. In this list though, each of these is the product of two functions of x squared times e to the 2x, x squared natural log x, 2x cubed cos 3x, etc, etc. Now, the interesting one is to look at the second to last one and to realize that actually what you've got there is a function that looks like y equals u v w, and then the derivative of that just follows a pattern. It's u dash v w plus u v dash w plus u v w dash. Crazy pen. So it's no different from the others. You just start off by saying let u equal e to the t and v equals natural log t and w equals cos t. And then you just need to find u dash, v dash and w dash and put it into the rule.